Hello students, I welcome all of you in TYBSc Mathematics class. For TYBSc Mathematics we have 9 courses. In first semester we have paper number 1 metric space, paper number 2 real analysis 1 and paper number 3 mathematics paper 3 dependent on maths paper 1 and maths paper 2. Today we'll start metric space. You are familiar with distance between two points, distance between two objects. Distance between two objects is always non-negative number. Or before that we will study the concept of absolute value of real number x. For x belongs to R, absolute value of x is x if x greater than 0 or greater equal 0, and it is minus x if x less than 0. Means absolute value of x is always the negative number. What are properties of this absolute value of x? So first one, absolute value of x greater or equal 0 for any x belongs to R. Second one, absolute value of x is 0 if and only if x is 0. Third, absolute value of x is same as absolute value of minus x. And fourth one, absolute value of x plus y less equal absolute value of x plus absolute value of y. This is known as triangle inequality of real numbers. What mod x denote? It is nothing but distance of real number x from origin 0 in R. So, what is the distance between AB belongs to R? Mod of A minus B. By applying these properties of absolute value function, we have d of AB greater or equal 0 for any AB belongs to R. Second, d of AB is 0 if mod of A minus B is 0, that is A minus B is equal to 0, means A equal to 0 if and only if A equal to B. Third, d of AB, which is nothing but mod of A minus B, which is equal to mod of minus B minus A, but it is same as mod of B minus A. That implies d of AB must be equal to d of BA for any AB belongs to R. 4, d of AB is nothing but mod of A minus B. Now inserting C there, adding and subtracting C, I can write this as A minus C plus C minus B, and then taking A minus C as X, C minus B as Y, I can write this as this equal mod of A minus C plus mod of C minus B, which is nothing but d of AB, d of AC plus d of CB. So, usual distance between two real numbers satisfies is d of AB greater or equal 0, d of AB is 0 if and only both numbers are equal. Distance between that 2 points is same if I count that from first point to second or second to first, and triangle inequality. I will extend this for any non-empty set X and will define the concept of metric. So, definition of metric and metric space. Let X be an empty set then function d from x cross x to r or close open interval 0 infinity is metric for x if it satisfies first d of xy greater or equal 0 for any two elements in x. Second, d of xy is equal to 0 if and only if x is equal to y. Third, d of xy is equal to d of yx for any two elements in x. 4, d of xy less equal d of xz plus d of zy for any three elements x, y, z belonging to x. If D is a metric, D is metric for x, then set xd is called as, or set x together with metric D is called as metric space. So by previous discussion, if I take d of xy is equal to mod of x minus y, then that d of xy equal to mod of x minus y satisfies all these four conditions. Therefore, set of real numbers is a metric. If x is equal to real number set or complex number or any non-empty subset of numbers, non-empty set of numbers, then d of xy is equal to mod of x minus y, xy belongs to x, define matrix for x. As this is the usual distance function, so this function is called as usual metric for set of numbers, and set x together with this metric is called as usual metric, and it is denoted by x to the suffix u. D is called as usual metric and xd is equal to x to the suffix u is called as usual metric space. As this is usual metric, means there is chance to define some other distances on set of real number or set of numbers. So what are the ways of defining other functions? For example, let x is equal to say r, d of xy is equal to under root of mod of x minus y, xy belongs to r. Now this is not usual distance. I am defining the function in this way. Then 1 d of xy is equal to square root of x minus y greater or equal 0. Second, d of xy is equal to 0 if and only if under root of x minus y must be 0 by definition of D. If and only if, so square root of 0 is 0, means mod of x minus y must be 0, and absolute value of number is 0 if and only if it is 0, means x minus y is 0 if and only if x is equal to y. So by 1 and 2, positivity axiom is satisfied by this function d. Third one, d of xy is equal to under root of mod of x minus y. I can write it as under root of mod of y minus x, because we know that mod of x minus y is same as mod of y minus x, which is equal to d of yx. So the symmetry axiom is satisfied. Now we have to verify whether D satisfies triangle inequality or not. Triangle inequality is the most important axiom while showing some function is a metric. Triangle inequality. So let xyz belongs to R. Then d of xy will take its bracket square, which is equal to mod of x minus y, because d of xy is nothing but under root of mod x minus y, taking square and square root will get cancelled. Then I will write this as I have to relate it with d of xz and d of zy, so I have to insert z here. So I can write this as mod of x minus z plus z minus y again and again, taking this as a, this as b. Mod a plus b is less equal mod of a plus mod b. So I can write this as less equal mod of x minus z plus mod of z minus y. So this is equal to d of xz its square plus d of zy its square. Then I will add 2 times d of xz, d of zy on the right hand side, which is positive number. So this is nothing but d of xz its square plus d of zy its square plus 2 times d of xz plus into d of zy. But this is nothing but d of xz plus d of zy bracket square. Taking square root on both sides, we get d of xz xy less equal d of xz plus d of zy. Taking square root. Thus D satisfy all axioms of matrix. Therefore, real number with respect to this function D is matrix space. Remember, this D is not usual distance, so it is not usual matrix. I am defining the distance in other way, which also satisfies all axioms of matrix, and hence it is a different matrix from usual matrix. Now, we'll think about some other functions, whether they defines matrix or not on R. Example number 3, for xy belongs to R, if I write, say d of xy is equal to mod of x raised to 2m minus y raised to 2n, where xy belongs to mn are natural numbers. As mn are natural numbers, therefore 2m and 2n are even natural number. In this case, d of 1 minus 1 is nothing but my 1 raised to 2m minus 1 raised to 2n. 1 raised to even power is 1, minus 1 raised to even power is 1. So mod of 1 minus 1, which is 0, for 1 not equal to minus 1. Therefore, positivity axiom fail. Okay, this implies d of xy is equal to 0 for x not equal to y. Therefore, D is not metric. D is not metric. Similarly, for D of xy is equal to, say, if I take mod of sine of x minus y. Again, for this D of, if I take 0 and pi, then I will get mod of sine of 0 minus pi, which is equal to mod sine pi. And sine pi is 0. Sine pi is 0 for 0 not equal to pi. Therefore, this function d is also not metric. Similarly, if I take the function d of xy is mod of cos of x minus y, it is not a metric. Now, if I take other example, say d of xy is equal to mod of 1 by x minus 1 upon y, xy belongs to r minus 0. Then whether this function is metric or not. So in this case, first d of xy is greater than or equal to 0, because for x and y, non-zero real number 1 by x and 1 by y are non-zero real numbers again, and then distance between them is always non-negative number. Second, d of xy is equal to 0 if and only mod of 1 minus x minus 1 by y is equal to 0 if and only 1 by x minus 1 by y is equal to 0 if and only 1 by x is equal to 1 by y, and then this is same as x is equal to y. Means they satisfy positive axiom. Third, d of xy is equal to mod of 1 by x minus 1 by y. Again, I will write it as mod of 1 by y minus 1 by x, which is equal to d of yx. For triangle inequality, what we have done for usual metric, we will use the same concept. So, I will insert the reciprocal of third number. For xyz belongs to r minus 0, d of xy is nothing but mod of 1 by x minus 1 by y, which is equal to mod of 1 by x minus 1 by z plus 1 by z minus 1 by y, which is less equal again mod a plus b less equal mod a plus mod b by triangle inequality for real numbers. So this is mod of 1 by x minus 1 by z plus mod of 1 by z minus 1 by y. By definition of d, this is nothing but d of xz plus d of zy. Thus d satisfy all axioms of metric Therefore, set of real numbers except 0 with respect to this function d is metric space, which is not usual metric. If I take fifth example, d of xy is equal to mod of x cube minus y cube, then we have to check whether it is metric or not. Again, for this mod of x cube minus y cube, it is greater than or equal to 0. It is 0 if and only if mod of x cube minus y cube is 0, then we will get x cube minus y cube is 0. X cube is equal to y cube. Therefore, x is equal to cube root of y. Okay, but we know that x cube is equal to y cube if and only if x is equal to y, which is not the case for even powers. Therefore, d of xy is equal to 0 must implies x equal to y. And again for triangle inequality, d of xy is mod of x cube minus y cube, inserting z cube, adding and subtracting. We can easily show that d of xy is equal to d of xz plus d of zy. Therefore, this function also defines metric for set of real number. Okay, then Rd is metric space. So thus we have studied some function defines metric for set of real number, while some doesn't define metric for real number. So with this, today we'll stop here. In next lecture, we'll study the metric for set of complex numbers.